Næstur Yngvi Björnsson með mjög spennandi erindi. Ég sé að fólk að flykkjast inn í salinn. Know the customers better than they know themselves. Þetta eitthvað sem mjög spennandi. Dr. Yngvi Björnsson is a professor of School of Computer Science at Reykjavík University. He completed his PhD degree in computer science from University of Alberta, Canada in 2002. Specializing in artificial intelligence, he joined Reykjavík University in 2004 and co-founded KDA Reykjavík University Lab. The following year, his research has mostly focused on intelligent search methods as well as intelligent software agents that learn autonomous from experience. He has taught classes on a variety of computer science topics, including advanced programming, algorithms, artificial intelligence, web mining, and machine learning. He has also served as a consultant to numerous companies in the startup and software sector. Yngvi, gjörðu svo vel, hlakka til.
Thank you. Hello. Is this working? Yes. Hello, my name is Yngvi, and today I'm going to talk about data analytics. So first, who am I? As it was introduced, I'm working at Reykjavík University. I'm a professor there in School of Computer Science, and I've been working in the field of AI for now over 20 years. In today's lectures, I'm going to talk about data analytics. However, before I start doing that, I'm going to talk a little bit about the terminology because it's very confusing. People are using the same terms for different things and different terms for the same things. So I'm just going to spend a few minutes just to kind of get the big picture of the terminology such that we can hopefully clarify a little bit the subject. And then I will give an overview about data analytics and with a special focus on the customer. And I'm going to take a few examples along the way of successful usage of data analytics in business settings. First, about the lingo. We heard about, like I mentioned, data analytics. We also have a term like data analysis, pattern recognition, predictive analysis, big data, data mining, business intelligence, machine learning, and it's no wonder that people get confused about all this. So I'm going to spend just one slide on giving a little bit of a big picture that hopefully will clarify things for you, not just for this lecture here, but just in general when you hear others talk about these topics. So we have these two sides of analytics, you could say. It's the technical foundation on the one side and the application on the other side. And in the beginning, there was statistics. And on the technical foundations, and then on the application, it was data presentation. So the data presentation in the beginning for the businesses, it consisted of just reports, quarterly reports maybe. They were using sums and averages for statistics. However, this became, over time, more major, and as both the computer systems became more powerful, and then with the advent of the computers, we were finding ways to have the computers process the data and come up with calculating various things. So they were concerned with algorithms. And this merits of statistics, and the same was for the data on the user side. We had like relational databases and queries, and making it actually more accessible to the end users, the data. They didn't have to rely just on the reports coming in every week. They have more kind of online access. But the merits of statistics and algorithms allowed scientists to actually start having the computers learn. So they were processing the data using state-of-the-art algorithms, and they were actually trying to learn autonomously on their own. And there are all kinds of things they were learning, not just that had to do with data analytics. It was just about robotics, how they behave, intelligent agents, and so on. But one application of this, the machine learning, was how to use this to try to get some insight from data. However, machine learning is focused. It's like a more technical term that's mainly focused on the algorithms we use for computers to learn. So anything that's to do with data analytics and is now business intelligence, we are using more and more machine learning techniques. But these, we are typically just referring to the techniques when we are talking about machine learning. And then there were other fields doing like the same. This was within computer science. The engineers was also using machine learning methods, and they called them pattern recognition, just because this developed independently, and the two fields were using different terminology. And then they found out the application for the techniques were more than just used for pattern recognition, and the term computational intelligence were introduced and so on. But this is all kind of focused on the technical side, describing the methods and the focus on developing methods that allow the computers to learn. Then on the business side, we had more and more like these data warehouses. And the talk, those of you that were here in the previous talk was give a very good overview of how data warehouses can be used. But the focus, as could be seen there, is mainly on processing the data, integrating from many different sources, and presenting the data to the manager for decision support. So it's making the information accessible to the manager and those who help them in making decisions. And this kind of, we had like now the importance of data, which became more and more relevant. We had more and more data, and we were focusing on applying these machine learning methods and statistics and algorithms in this particular task of taking historical data and trying to process it and get some insights from the data. And that is basically the term kind of a data mining, but still, in the beginning, when we start talking about data mining, it was still very technologically focused. You were thinking of how, from technical point of view, what can we do with, how do we process big data? We need fast databases. What do we do if there are missing values? What do we do with incorrect value? How can we build algorithms that don't, the estimate, the predictions are not biased because of that? Whereas on the other side, what we call business intelligence, they were more thinking about the human side and how do we present the information we have. We take the data, we apply some methods to get some useful information out of that, and then we're trying to present that to those who are taking decision, hopefully helping them to get more insight. But then we started to realize, well, the one cannot be without the other. The business intelligence, really, it was not enough that just the humans were coming up with the insight. We had so much data that we are relying increasingly on the computers to come up with the insights. And for that, you need to have advanced data, machine learning and data analytics techniques. And then we started to talk about data analytics or data analysis, and this is basically we were marrying these two concepts, because the same thing was on the data mining side. It's not about technology. So if you want to do any data mining, the first thing you have to do is to know what to ask for. And to be able to know what to ask for, you need to have some insight into the data you're working with from the business perspective. So then we talk about data analytics. And now we are there, and that's what I'm going to talk about you. But it's a little bit more complex than this, because we also have now this buzzword, or what is being talked about now is a big thing, is the big data. And what is big data? And many people use big data basically in the same way they talk about data analytics, and that's wrong. Big data is basically just about, if you have so much data that you cannot easily process it on a single or few computers, how can we, what do we need to do, what techniques do we need to do to be able to scale that up to huge distributed systems? And of course, data analytics is one of the primary uses of big data. But it's not big data. And now, if you have a lot of data, we need typically to use big data technology to do data analytics on a large databases or real-time data. So this is how that comes into the picture. And now we're hearing the term big data analytics. So this is just a background, and hopefully this is going to be helpful. And now I can start talking about data analytics. So what is data analytics? It's basically, we are taking data, and data is basically just the raw data itself, and we are turning that into valuable information that becomes knowledge and will lead to some insight. So if we need the data, we need to process the data somehow to gain new insights. And like I said, in the beginning, the humans were mainly responsible for this, but we have been relying more and more on the computers to do that just because of the volume of data as well as the real-time constraints. Sometimes we have to make decisions in real time, and there's just no way we can process that in a human-like way. But the key thing of both this is that in the end, this has to lead to some value. Value for the business, value for the customer. So it's not just that we just start digging somewhere to find something useful. We typically want to know at the least what to look for. Why data analytics? Well, there's a lot of value in the data. And I think companies all over the world and businesses are now realizing that the value lies in the data. And we're even now talking about the new era of gold digging. We're not digging in rock for gold, but we are digging in data for information. And many of the even biggest companies today, Google and Facebook, this is basically the concept behind why they exist and why they are so successful businesses. It's about basically collecting the data and then take that data and somehow create some value. And it's not only important for big companies, it's good for small companies as well, startup. There's a new model in the last 10 years, 5-10 years, the way that you should create a startup has changed. It's really very much about just throwing things at a wall and just see what sticks. And you need to have a very good data analytics to be able to get a short turnaround time for that. So it's changing the world. And it's important that this is creating value. It's value for the customers and the businesses. And typically, if you create value for the customer, that translates also into value for the company. So it's increasingly relevant for businesses for staying competitive in today's world is to know your customers. And ideally, you want to know the customer better than the customers know themselves. And as you can see, this is an overview of where data analytics is used by businesses in what field. And you can see the most common field is the customer relation management. It's about knowing things about the customers. And this is by Rexer Analytics. They have this biannual survey where they have been looking into this, and this has always been on the top. But you see also the retail, financial sector, and others that are using it, but the customer management relation seems to be the primary use. So it's knowing the customer, and that's no new truth to that. It's always been important in business to know the customer. And the person, like the hardware shop on the corner, the owner there, who's typically working in the store, her or himself, they knew the customers that came in, and they knew them personally. When Joe came in, he knew that Joe was fixing his roof. And so he could say, okay, I just got in a new paint that will be ideal for you to paint the roof after you fixed it. So they basically knew the customer very well and were able to sell the customer directly. It's a very personable service, but it's not scalable. And this is why these small stops if it can be replaced by the big supermarkets. And however, it's also important for the supermarkets to know the customers. However, they cannot do it on the same individual basis, but they can nonetheless do that. And this is, for example, the reason why you are having a discount card at your supermarket, so the supermarket can connect your purchases to you personally. It's basically worth to give you a 5% discount just to be able to know your purchasing history. This is a better scalable, but it's not personal. So the supermarkets are typically looking at goods that sell well. They are basically aiming for the masses. So if there are few people fixing the roof, it's not good for that store to try to sell things to the customer the same way as the hardware, the guy in the small hardware shop was doing. But it's changing. And now it's not just about knowing the customer. You want to know them individually, even though you never see them, even though they are shopping in a different continent. You can have an online shop. You never see your customer. You still want to know the customer, and not only know the customer, you want to know the customer better than the customer knows him or herself. We all had the feeling like you get some kind of recommendation to buy a new book or listen to a new song, new artist, and you think about yourself, wow, I really enjoyed this song or I really enjoyed this book. I would never have thought that I would like this. And this is basically, well, the computer system is starting to know you better than you know yourself. And in a very recent study, it came out last year, it's scary actually to know how much someone can know about you just by observing what you're doing on the World Wide Web, on Facebook and other media. It showed basically there was a personality test that hundreds of people took, and then the spouses and the family and friends of those persons were asked about the personality, and of course the spouses knew their spouse the best. The second best in knowing the personality profile of those people that took the personality test were not the family, it were not the friends. It was a computer program that just went through what they had been doing on the internet, looked at the profile. So it is possible to know the customers better than they know themselves, and you want a fully scalable model for that, and you want to do it in a personal way. And this is basically where the thrust now in data analytics is actually to have a fully scalable, personalized methods. So data analytics techniques, there are many types of those. I'm just going to give a very quick and incomplete overview of the most common ones. Classification is one of those. I will talk about it a little bit later. Clustering analysis, affinity analysis, and this is also that's very hot now. We will talk about that, and many, many, many others. And the key point here is we are going far beyond just finding correlations. Here is a graph. It's looking at two variables over a period of 10 years or so. The yellow line is the total revenues generated by skiing facilities in the US, and you can see it's highly correlated with the number of people who died by becoming tangled in their bed sheets. And it's 97% correlations. So if you're still just relying on correlations in your analysis, you are losing the game. So let me talk a little bit about these main classification techniques. It's the classifications. Then we have some historical data, typical in a relational format. This could be information about customers. For example, here, each row here is information about a bank client or customer, and has some information about the customer, and it's used to decide basically what we call the dependent variable or the predictive. The variable we want to predict is here, should we give this client a loan? Or is it likely to default on the loan or not? Do we want to grant the loan? And we have historical information where we know for those customers is basically if they defaulted to the loan or not. And we use this data to build a model. And the model, and here we use the machine learning techniques to build a model. And the model you have many, many different kinds of models. You might have heard of neural networks. That's just one type of model. You might have like a decision trees like here. That's a different kind of model and so on. But the big picture is always the same. We take the historical data, we build a model that we use to predict about unseen customers, unseen instances. So now there's a new customer, and we have this model that we built from history of the last 3 years or so. And here is a new customer, and we want to know if we should give this customer a mortgage. And we have some attributes information about the customer. What is the annual income? Does he have a car? Is he married? And so on. And we ask the customer these questions, feed that into the model that we built, and it's going to give us an answer, yes. Or it could give us also some kind of a confidence interval also in the answer. So this is classifications. We basically have data that has been labeled. There's one variable one or more variable you want to predict, and we label it. And this has been pre-labeled by someone who knows what the right value should be. This is sometimes why we call this kind of a learning, supervised learning. And we built a model that we use to predict for unseen instances, new customers. Then we have techniques which is called clustering, and that it's not particular things we are trying to predict. We have a group of customers, and we want to learn something about them. That's the output of this. It's not that we're going to build a model that we're going to use to predict something about unseen customers. We want to learn something about the customer base that we have. For example, we can look at it and we can find out there's a group of customers that seems to be more like-minded, that they are somehow more homogeneous in the way they act than some other group of customers. For example, like this blue one, these could be customers that are very price conscious, whereas this group here may be more concerned about the quality of the product. And this means that once you've identified the different types of customers, you can have target marketing towards each one of them. And then we have what is called affinity analysis, and there are many techniques there. And here we are trying to find co-occurrence relationship in the data. And for example, one use of this frequent use is what is called the market basket analysis. So if you're an online shop or a grocery store, you basically just look at all the transactions, and you figure out kind of what kind of goods seems to be bought together. For example, if you buy milk and cheese, you're very likely also to buy bread. And what it means once you have this information, maybe you want to put them next to each other, these items, these goods, or you want to have them different parts, different ends of the store. So you force the customer basically to walk back and forth like IKEA, use the IKEA model on that. However, this is just looking at the whole. It's not individual. It's not personalized recommendation. But now, and this is the talk of the town now, there's a recommender or recommendation systems, recommendation engines. Again, a lot of different terminology for the same thing there. And there we can actually provide you with personal recommendation. So it's more like that. Okay, you have this very obscure taste in food or music or whatever. So you're the only one in the store that buys this 3-year-old goat cheese or something like that. However, that doesn't mean that you cannot be recommended what to buy. So this is more like, again, we have some history, and we kind of figure out that you seem to have very similar preference to this guy Bob that lives in a different state in the US, buys in a different shop. But he also likes this kind of goat cheese very much, and he also likes sourdough bread or something. So we could, based on that, say, oh, you and Bob seem to have a lot in common. So maybe because Bob also likes this particular cheese, maybe you should also try this particular bread. So, and this is the thing that we are trying to do, and this is something we call that we are hitting the long tail. So these recommendation systems allows us to do personal recommendations, and one way to explain this is through this long tail. So if you're just in a traditional sales, where you cannot have target like your customer personally, you go for the bulk, where you have few products and you advertise them. And when you're advertising, you're trying to hit those items that you are selling the most and give you the most profit. This means you're only advertising towards those typical customers. And you're missing out over maybe the largest half of the customers. They are not as uniform on these. They are more... they differ and have different preferences, but nonetheless, the sum of them is still the biggest part of your customer base. And once you start doing personal recommendation, you can now basically recommend everyone. And this is the reason why we have shops like Amazon, they can carry this almost every book that has been published, even though they don't sell very much, because they're not, unless like the local store, physical store, where you go, they cannot carry every title, so they have to go for those books that sell well. An example, I don't know if you heard about books and movies. There were books called, was called Into Thin Air, about the Everest expedition that went bad and people died. You know about that? Krakauer was the other. And this was very prominent when this happened, this event, and was known worldwide, and then there came the book, and the book was the bestseller. There was also another accident that happened in South America, in Peru. There was these two guys climbing this mountain. On the way down, one of them broke his leg, and they were going down, and unfortunately, one of them, the one with the broken leg, he went over a cliff, but they were actually in a rope, and the other guy was sitting on the edge of the cliff, and the guy with the broken leg couldn't go up, and the guy that was up there, he didn't have the strength to pull the guy up. So he was in a dilemma. He tried to hold on as long as he could. At some point, he had to cut the rope. Fortunately, actually, the guy he survived. It was a miracle, and actually he came here and gave a lecture, this guy, a few years back. Joe Simpson, I'm not sure if you went. Anyways, there was a book written about this, but no one knew about this event, and it didn't sell very well. But then this recommendation system picked up that some people, only very few people that read the Krakauer book, happened to read this book and like it as well. So it started to recommend that, and in the end, it actually became a bestseller and outsold the Krakauer book. So just then before I end, I just wanted, because I get asked a lot about this, what data analytic tools are companies doing? And again, I'm referring to the same survey as before by Rexer Analytics. And so the green color is like the most frequent tool you're using. So in data analytics, typically you use not just one tool, you use several tools. And the green is the primary tool used. The light green is the secondary tool. And then the orange is like frequent use, and occasional use is the blue. And you can see the statistical package, like, or not just statistical, is machine learning package R. This is a free software, is by far the most popular. But this is followed by the big commercial packages like SPSS, SAS, and Statistica. And then there are others as well here. So it's good to have this, just because I get asked a lot about this. And you can see also, like now, the database systems, they already also have many analytics tools embedded into their servers, like the Microsoft SQL Server and Oracle. And just to summarize quickly, historical data is valuable. We use data analytics to turn the data into valuable information, and we are increasingly relying on the computers now to come up with the insights. And just these traditional techniques we've been using, like in the business intelligence for visualizations and other things, they work well, but not on their own, because we are now, like I said, we have so much data, and we have to take increasingly decisions in real time, and just it doesn't work always to have a man in the loop. And so we are relying increasingly on these analytic tools. And the truth is that it's increasingly important in the today's world for businesses actually to know their customers better than they know themselves, use complex analytics to do that, just to stay competitive. So I think that is maybe the main message from this talk. And if you want to learn more, then I will be here at the Reykjavík University booth during the lunchtime. And if you want to know more about this, or what the Reykjavík University can do for you in this manner. So that's it. Thank you very much. And the floor is now open for questions. One question. Yes. Thank you.
Do you find that now that we have maybe finally embarked on a fast train towards getting more information on the customer than even he knows himself, there are maybe implications regarding their privacy that we need to look at and reason to look at for?
It's a very, very good question. Like the question was, now that we are on a fast track in knowing more and more about the customers, are there some privacy issues we have to think about? Because we can collect and we can know a lot of information, and sometimes it's scary, like the example I talked about. This is absolutely true. And this is now, you can hear this more and more debate on this. What should we do with this data that we have? And this is something like, this is very typical, like the infrastructure, the law are always tailing the technology, and the same is now with the drones, for example. But this is something that is very relevant, and we really, really have to think about. And for example, the Facebook terms changed, like at the beginning of this year, that they can do more or less what they want with your data in the statistical, not to reveal anything about you individually for publishing, but just for using that information in the way they like for advertising and so on. Definitely, this is a big thing, and I have one example regarding this. The second largest retail chain, or the stores in the US, it's called Target, and they were very, very early on understood the value of data analytics. And they wanted to, and they realized that new parents are very valuable customers. Why are they valuable, new parents? Well, first of all, you have to buy a lot, but secondly, time is of an essence. So you really want to go to one store to buy everything. You don't have much time to compare prices. You just are looking for convenience. You don't have the time. You're saving on time. And okay, so in the old model, when the grocery stop on the corner, you could see that the customer was pregnant, no problem. But they wanted to know this Target actually before the baby was born, because they want to make sure that you were coming to them. And so they were trying to predict, just from the purchasing history, if the customer, a woman, was pregnant or not. And they could do this with surprisingly good accuracy. So they started sending brochures to those homes with special deals on baby clothes and diapers and so on. And there was a father that called in mad. So why are you sending these baby brochures to my 16-year-old daughter? Are you encouraging her to have a baby? She doesn't know what sex is. And the manager called 2 days later something to apologize for this, but then the father apologized, said, sorry, actually you were right, she is pregnant. And then people started to say, like, they came this nickname slogan, like Target knows before it shows. So definitely there are a lot of privacy issues. Thank you.